So now today we will study about the psychometric chart, right? Here you can see a psychometric chart, right? So now this chart is very much important, right? When we are going to solve questions related with HVAC system. So now let's discuss about air conditioning and human comfort, right? So now if you are going to consider about human beings, right? The human body cannot handle every type of temperature conditions, right? That means, for an example, like if the environment is too much hot, then definitely human body cannot handle that, right? Or in other words, if the environment is too much cold, right, then also the human body cannot handle that, right? So now definitely now it is so clear that there is a safer and also a kind of a comfortable temperature, right, that is there where human body can comfortably bear, right? So now as the role of HVAC engineers, right, definitely they cannot actually change the weather, right? But actually as HVAC engineers, right, they can control the conditions, right? They can control the properties, right, of the control volume. For an example, like if you are going to consider a particular room, right, by introducing a suitable air conditioning system, right, they can actually control the parameters of that particular control volume, right? Right. So now actually we need the help of psychometric chart, right, in order to determine the physical and thermodynamic properties of moist air, right? So again I will tell that. So if I am going to consider psychometric chart, right, PSYCHRO, psychometric chart, right? So this chart actually we use to determine, right, physical and thermodynamic properties of moist air, right? Right. So now actually then you might be asking this question, right? Then what is actually moist air? Because now some students are telling we use psychometric chart to determine physical and thermodynamic properties of air, like without saying this moist part, right? But I will give marks for that also, right? But the better way is that when you are going to say, better say, we need psychometric chart in order to determine the physical and thermodynamic properties of moist air. Because the reason, right? Because if you are going to consider air, right? So if you are going to consider the surrounding, right? The surrounding air, right? It contains water vapor, right? So that means what is moist air? Then what is moist air? Then moist air means, right, very careful, that is dry air plus water vapor, okay? Dry air plus water vapor, right? So that is very much important for you to know, right? So now when referring the psychometric chart, right, we should know, like we must identify, right, what is the meaning of these lines, right? Okay, I will attach a psychometric chart, right? I will attach the link, right? So now we need to identify like what is the meaning of this particular line, right, and what is the scale, right? So now we will see how to read the parameters, right? So if you are going to consider the psychometric chart, right, so just like focus here, right? It actually appears like a boot, right? You see that? So now I will sketch it like this, right? So it actually appears like a boot, right? Okay. So now the other thing that if you are going to consider the psychometric chart, now this chart is actually constructed for a particular pressure, right? Actually now the chart that I am referring, that is the what is the most common chart. So this chart is actually constructed, right, for atmospheric pressure, right? Atmospheric atmospheric pressure, right? So what is that? What is atmospheric pressure, right? Atmospheric pressure is 1 atm, right? So 1 atm means 1.01325 bar, right? Okay. And there are psychometric charts that are available for other pressures also, right? And fine. Now we'll see how to read a psychometric chart, right? So now in the psychometric chart, right, you can see vertical lines, right? Vertical lines. Now these lines are actually vertical, okay? So now these vertical lines, right, denote dry bulb temperature, right? I will write it here, dry bulb temperature. Right? So now so if I am going to consider this chart, right, the dry bulb temperature increases towards the right side, right? Starting from -5, -5 degrees, 0, 5, 10, 15, 20, so like that, right? So if we're going to consider this chart, right, these vertical lines, right, denote dry bulb temperature, right? So like that we'll see like individually we will consider, right, what are the different types of curves, right? Then actually it is easy after that, because I don't want to give a bad image, right, that psychometric, the referring the psychometric chart is very difficult. No, actually it is not difficult, right? If you can clearly identify the meaning, then you can easily do, right? Okay, then I will again sketch this boot, right? Rather than sketching on the same chart, right, I will again sketch. This is the same chart, okay? Again I will sketch a boot, right? Okay. So now, right, in this psychometric chart, right, there is a line that is inclined at an angle 70 degrees with the left horizontal, right? There is a line like this, right? Roughly, right? There is a line like this, right? That is roughly inclined at an angle of 70 degrees, right, with the left horizontal, right? So these lines indicate specific volume, okay? Right. So now here actually the specific volume means it is actually the specific volume of the mixture, right? Specific volume of the mixture in meter cube, right, per kilogram of dry air, right? So now this is here I only teach you like what is the meaning of these lines, right? These lines and curves, right? So after that, when we are going to solve a problem, then you will meet the real life scenario, right? Right? But the most important thing is that first of all you must know what is the meaning of these lines with correct units, right? So it is specific volume means, right, that is actually the specific volume of the mixture, right? Right? Because now if you are going to consider the surrounding, right, it is actually a mixture of water vapor plus dry air, right? So now there is another line, right, that is actually inclined at an angle like this. So roughly if you are going to consider the angle, right, there is another type of a line, right, that is inclined at an angle of roughly, right, 25 to 30 degrees with the left horizontal, right? 25 to 30 degrees roughly with the left horizontal. See, this is from the left. Let's say 30 degrees, right? So like that. Okay, right. So these lines indicate wet bulb temperature, right? Okay. Let's discuss the other curves, right? So now I will again sketch the shape of the psychometric chart, right? So now we know it has the shape of a boot, right? Right. So now let's study about another curve, right? So now what are these curves? See, like this. Actually these curves, right? Curve number 1, curve number 2, right? And curve number 3, number 4, 5, right? I will sketch another one. So now we have curve number 6, right? So these curves are defined as relative humidity, curves, right? Okay. So actually, if you're going to consider this curve, right? This is the curve, right? This one, right? The outer curve, right? Where the shape actually ends, right? This is the 100% relative humidity curve, right? So what is this one? This is the 100% relative humidity curve, right? So now there is a doubt, actually what is this relative humidity? So let's first study that, right? Relative humidity is actually, it is a ratio, right? Relative humidity is the ratio of the actual mass of water vapor, right, divided by the maximum mass or the maximum possible value that air can actually hold at that particular temperature. Let's write MVAP, right? That means like mass of water vapor divided by mass of maximum amount of water vapor at that particular temperature, right? Relative humidity curve, right? It goes like this, right? Now this curve is the 100% relative humidity curve, right? And then 90%, 80%, 70%, like that, right? So now actually, like when you're going to consider about that human comfort, right? So now whatever the environmental condition, right, the human body must get adapted to a safest temperature, right? Otherwise it will be very much disastrous to the human body, right? So actually then it is the now human body cannot automatically get adapted to that sort of an adjustment, right? So that is why we need an air conditioning system, right? Because like human body cannot every time, right? What I say is like human body cannot every time get adapted to that temperature change, right? So it is quite practical, right? So that is why as HVAC engineers, right, they are working hard to provide a safer environment by introducing a proper air conditioning system. Okay, right. So now we will see the next one, which is the humidity ratio, right? Humidity ratio. Okay, right. So now I will again sketch the psychometric chart, right? That boot shape, right? So now here, if I'm going to consider the horizontal lines, right, that are going like this, horizontal lines, right? So these horizontal lines, right, represent the humidity ratio, right? And there is another similar term, right? That is, we call it specific humidity, right? And actually, what is humidity ratio, right? Humidity ratio, right? For that, we are going to give a special letter, right? Or special symbol, right? That is what we call omega, right? I think you have heard this word in circular motion, right? Okay. So anyhow, humidity ratio, or in other words, the specific humidity, right, is given this symbol omega, right? Or letter omega, right? So that equals, right? That is the amount of water vapor, right? Amount of water vapor divided by the unit mass of dry air, right? So that is the amount of water vapor that presents in a unit mass of dry air, right? So the unit will be kilogram of moisture, right? Kilogram of moisture per kilogram of dry air, right? Okay. So if I want to consider this psychometric chart, right? So these horizontal lines, right? See, like that. So these horizontal lines, right, represent the humidity ratio, right? So humidity ratio, it actually increases, right, towards the upward direction, right? So if you are going to move upwards from here, right, the humidity ratio, in other words, the specific humidity increases, right? So when considering values, let's say something like, starting from the very bottom, it is 0.001, 0.002, right? So like that, 0.007, right? So, and also be very careful about the unit moisture content, right, or the amount of moisture, right, that presents per unit mass of dry air, right? So that's all about the humidity ratio. So now let's see how to identify specific enthalpy lines, right? So now I will again sketch the boot. Okay. Right. So now here I want to tell you something, right? So now I have already taught you, right, about the wet bulb temperature lines, right? So now we know that if I want to consider the wet bulb temperature lines, right? So those lines, right, make an angle of 30 degrees with the left horizontal, like this. Just focus here. So now these are actually wet bulb temperature lines, right? So now actually if I am going to consider specific enthalpy lines, right? Now actually these specific enthalpy lines, right, lie very nearly parallel, right, to the wet bulb temperature lines, right? So now here the technique is, right, the same lines that you have sketched in order to denote the wet bulb temperature, right? So now same lines, right, are extended, right? See, it is the same line, right, not a different line. Same lines are extended to another different scale, right? So now that scale we refer as the scale for the specific enthalpy, right? So what are the units? The units will be kilojoules per kilogram of dry air, right? So that's about the specific. Let's see how to find the dew point, right? So now if you are going to consider the dew point, right, it is not something that you can directly find, right? There is a procedure or a method for that, right? So let me teach you that. So now I will again sketch the boot again here, right? See, so this is the boot, right, that I have previously taught you, right, from the psychometric chart, right? So now, right, so like this, okay, I will include only the required things, right? Otherwise it will be difficult for you to understand, right? Okay, so now our target is to find the dew point, right? So now so far I have taught you all the basic parameters that you can find, right? So now if you are going to consider the psychometric chart, right, when referring this psychometric chart, right, you need to know at least two things, right? That means two particular parameters you must know, right? That means you must know two parameters, or in other words, let's say two inputs, right? Like two facts you must know, right? So now, so far what are the facts that so far we have studied, right? We have studied about humidity ratio, right? Relative humidity, and then dry bulb temperature, wet bulb temperature, specific volume, right? So like that there are many parameters, right? Specific enthalpy, right? So now if you want to find the dew point, right? Like if you want to find any other parameter, right, by using the psychometric chart, right, be very careful. You should at least know two things. That means like you should at least know two parameters, right? So without that you cannot proceed, right? Okay. So now let's say for an example that we want to find the dew point, right? So now let's say that dry bulb temperature is given, and also let's think that humidity ratio is also given, right? So now actually there are like many ways, right? In case if another two parameters are given, then it will be like different, right? So be very careful. So now just consider we are actually given two parameters. One is the dry bulb temperature, and another one is the humidity ratio. So now we know that humidity ratio goes in a horizontal line, right? Right? It goes like a horizontal line. You know that, right? So and dry bulb temperature, right? Dry bulb temperature, you know that it goes like a vertical line, right? Because the lines are vertical, right? So that is the dry bulb temperature. Now let's say here we have a particular dry bulb temperature, right? Like this, and we have humidity ratio given. So now from this vertical axis, right, you can locate what is the dry bulb temperature, right? So then from here you can locate the humidity ratio. Now see, you will be getting an intersection. Understand? Right? So you will be getting an intersection, right? And now I have told you that this is the saturation line. What is this one? Saturation line. That is 100% relative humidity line, right? So then from here you know what is the if you know the particular dry bulb temperature, let's say for an example 25 degrees Celsius, and if you know the humidity ratio, let's say humidity ratio 0.011 kilogram of moisture per 1 kilogram of air. Let's see how to find the dew point temperature, right? So now you know that in order to find the dew point temperature, right, first of all, like when referring this psychometric chart, right, we need to know two things, right? That means definitely we need to know two inputs, right? So one input is the, according to this problem, one input is the dry bulb temperature. Okay, so now that is known. What is that? 25 degree Celsius, right? Other input is, or the other given parameter is the humidity ratio, right? So what are the units? Kilogram of the moisture per 1 kilogram of dry air, right? So now what is the humidity ratio that is given? That is, just focus here, 0.011 kilograms of moisture per 1 kilogram of dry air. So that means 11 grams of moisture per 1 kilogram of dry air, right? So that is known. See, 0.011, right? This one, okay, 0.011. And now from here, right, you can see this horizontal line, right? See, this line goes horizontally, right? So now just come from this horizontal line. Okay, fine, come, and be very careful. Now find the vertical intersection that is coming from 25 degrees Celsius dry bulb temperature. Where is it? This is that horizontal line, right? And now I am at, now here there is an intersection, right? Can you see that? Now just focus 25 degrees Celsius dry bulb temperature, right? And there is a vertical straight line, right? Or a line that goes vertically, right? Until it touches that horizontal line that comes from the humidity ratio. Got it? Right? So now here there is an intersection. Can you see this point? So this is the point of intersection, right? So this point of intersection, right, you project again horizontally, right, until it touches the 100% relative humidity curve. Can you see the last curve? This one? See, this is the last curve, right? Something like a, sari. Okay, it's very easy to remember like that. So now again let's come again. First of all, focus here 0. Have to focus. Okay, 0.011, it's here, right? Okay, from this line come and carefully come, right? And focus where you find 25 degrees, come. Okay, here, right? So now this is the intersection, right? Okay, so now follow this and project this point of intersection, so it will direct you to here. Now carefully focus this point, right? Now you know, let's focus again, right? It will direct you to here. See here. Now be very careful, that will direct you to here, right? So now from this curve you can read the dew point temperature. Now actually when reading the dew point temperature, you are actually going to read it from the wet bulb temperature scale. Got it? Right. So now see, now this is the point of intersection when the previous point of intersection is projected until it touches the 100% relative humidity line. So it is here. So now we know that point of intersection, right? Now be very careful. Now take the ruler, right? So now we know that wet bulb temperature goes in this type of lines, right? See, you know this line. I have previously taught you, right? Now see these lines, see, just focus these lines. These lines are actually making an intersection with the left horizontal to an angle of approximately 25 to 30 degrees, right? You got it, right? So now take the ruler. Now we know the point of intersection. Now we are going to read the dew point temperature, right? Okay, let's focus again, right? Now got it? So now, is it at here? No. Because like if it is exactly at here, then the dew point temperature is 15. It is not there. And if it is here, then what is the dew point temperature? Then it is 16. If it is here, 17. If it is here, 18. If it is here, 19. If it is here, 20, right? So now again come back to here. Now we are going to read it from our eyes, right? We are not using any, we are not going to use a computer or whatever, right? So we are going to read it manually, right? So now keep it here. So now just come parallelly up to here. You got it? So then now you can very clearly see that this line, right? Like when I reach parallelly from this 15 degrees Celsius wet bulb temperature line to here, it will direct at somewhere here. Got it? Now see this line, right? Now see this line is actually in between 15 and 16. You got it? Now this is the parallel line, right? That I obtain when I parallelly, when I come parallelly with respect to 15 degrees Celsius line. So it will stop at here. Now it is so clear that it is a value in between 15 and 16, right? It is a little bit, in between, right? So it is somewhat similar to a line that is right in the middle in between 15 and 16. Okay, so let's call it 15.5. So what is the dew point temperature when wet bulb temperature? So what is the dew point temperature when the dry bulb temperature is 25 degrees Celsius and the given humidity ratio is 0.011 kilograms per kilogram of dry air? So the answer is